Welcome to Callous Coder. Don't be a Git, learn it. From zero to hero in Git in 25 minutes. Motherfucker! So today we're going to learn Git. Sure, we will revisit all those basic steps that all the tutorials before us have done, but then we will move above and beyond. We will solve merge conflicts, we will explore rebasing, we will talk about tagging, we will set up our repository for pull requests, and we will talk about proper use of branches. So let's jump in and have some fun. Ever since August 2021, you need user tokens to use Git. So let's first create one of those. Let's go to Settings, then click Developer Settings, and then create a personal access token. Each user should have its own token. That way, when you leave the company, they can revoke the token and you can no longer have any access to the repositories. And there are roles associated with these personal access tokens. I'm just going to click all the repository tokens. Then I can do everything on the repository. I don't need any webhooks. So I think this is it. We can always extend it. Oh. And I set it to 7 days valid and we give it a note. Because after 7 days this video is live and this token will be revoked. You need to copy the token and you need to save it somewhere. You're going to need this. A lot. Now we can create a repository. Click on New. Then give the repository a nice descriptive name. Fill out a nice description. And choose whether it's a public project or private project. This is a private project. And I add the readme.md file. Whenever GitHub finds a readme.md file, it will show its content. And you can actually mark it up quite nicely like HTML. So you have a nice piece of documentation with your code. Then we add a gitignore file, and there's a lot of gitignore templates here. For most languages, it's already there. You just select one, let's say this is a C++ project, and you can actually extend this .gitignore file with extra things you don't want in your repository. Then we click Create Repository, and in a few moments we have a nice empty repository with our readme.md file and our .ignore file. And you can actually extend this .ignore file with extra files that you don't want in your repository. So now that we have a user token and a repository, we can actually clone it. So click on the clone button, click on the copy button, and that way the URL is copied. That way you don't need to type it in. Git space clone and then paste that URL in. Now copy your token and paste it behind the / and put an @ sign behind it. Now all consecutive calls in this repository will use this token. So you don't need to provide it anymore. And it has been checked out, so let's look in the directory. And there we have the contents of the repository from GitHub. So now that we have a nice clone of our repository and we're in that directory, we will use the git status command. This is a very useful command. Git status will show you the branch that you're currently on and if there's anything to commit or not traced. So now we're ready to create a file, but we're not going to do this in the main branch. We're going to create a branch. Now there are two ways to create a branch. The first is git space branch space and its name. For example 123, because I use always the story numbers that I'm working on, those are basically features, as a unique name for my branch. So now we have created a branch. So we still have the code, but when we run git status, we see we're still on the main branch. So we need to do a git checkout in order to change branches from main to 123. Git checkout and then the branch name. And now we are in the branch 123. But there is a quicker way. This takes 2 steps. So let's go back to our main branch. Let's delete the old branch with git branch -d123. Now it's gone. and we do a git checkout -b and then the branch name. And the branch will be created if it doesn't exist. And then automatically switches us straight into that branch. So this is the more efficient way, git checkout -b. So now that we're safely in our own branch, we can create a test.cpp file. This is our unit test. This is test 1. This is very, very good C++ code that will definitely compile. And now when we run git status, we will see that we have in our branch 123 a test.cpp file that is not tracked, it's red. In order to bring this file under control of Git, we will need to do a git add. We can do git add and the whole file name, but you can also use wildcards. In this case, we add all the CPP files. Now when we run a git status, we will see that the file is actually under control of Git and it's staged to be submitted as a new file. In order to submit this as a new file, we have to commit it. So any change to a file will require a commit. And we do that with git commit, and I always use -a. The reason I use -a is that if you have a lot of these files under control of Git and you rename them and you delete them when you do a refactor, then usually you would have to manually do a git rm of that file or a git mv of that file, and the -a just follows all these changes and submits them. So that is far more convenient. And then I do a M for a subject field. And I will type a one-line subject. I always start with my story number. That way you can always look back at the story for testing purposes, see if you have all the functionality. And then a one-line description. Some companies want a one-line description and a whole bunch of text. You can do that as well by just doing -a. So now that we have our feature in our branch 123, we're going to merge it into the main branch. So we're still in branch 123 and we want to merge it in the main branch, so we have to check out the main branch and then we do a git merge and we type in the name of the branch that we want to merge on the main tree. We press enter and then it's merged. No merge complaints whatsoever, nice. And we can validate our code, our test file is there, and our absolutely perfect C++ code as well. So now that we have tested our code, we know that it works, we can push it to the centralized repository. Just type git push and there it goes. Now git push knows automatically where to push it to when you cloned the repository, and it will always push it to that repository. So if we refresh our code here, we will see test.cpp and there it is. That is our code. If you however started with a local repository, then you don't have a remote repository yet. So you would create a new empty remote repository and then you will set your upstream to that remote repository with this command. Git remote set URL origin and you type in the URL. We will just put in the same URL. You do need your token again. And basically in this example here, we changed our upstream to this repository, which is still the same. So imagine that another developer is also editing this file. This is test 2. He added a nice test. And this bad boy actually edited on the main, which you should avoid as much as possible. So obviously after the commit, his changes will be reflected in the file. But when we look at our local file, those changes have not yet been propagated. It's not there. That's because we need to pull the changes from the upstream with git pull. And there you go, it pulled them from the master, and now we should have that test 2 there. Now you did notice after your first pull that you got a lot of configuration hints. There are basically 3 configuration strategies. Personally, I use config pull rebase true a lot, because that allows you to flexibly merge a lot of different branches together. It comes at a trade-off that the history of all the commits are changed, they're not the same, and that confuses a lot of developers. So on big projects people use config rebase false, which is the default. Merging different branches with rebase false can be a tremendous pain, but at least all the commits are there and the developers who actually committed that code know what it is, and that will help. So let's use that. Up till now, all this information is available in all other tutorials, but we will push on and create a merge conflict and a pull request. So we will have our pretend programmer here change this line of code, and we are going to change that same line of code, creating a merge conflict. Let's put this between quotes so we actually know what is what. And this bad boy is actually committing on the main. That is a very bad practice, as you should know by now. But we are going to be bad boys too. We forget to do a git pull. So we are here in the main branch. We will create a new feature branch using the git checkout-b methodology, because that's the quickest. We're going to edit the same test.cpp file, and we're going to add it on the same line. That way Git has no way which is leading code and cannot merge it. Let's commit it again. Now we do a merge on the branch. So we check out the main. We want to merge it on the main after all. Git merge 1 to 5. That looks good, but now comes the push. And this is where things break apart. It says that there is changes in the upstream that we don't have. So we should do a git pull. So when we do a git pull, pull is with double L, thank you, we will be confronted with a nice little error message. Conflict. I would have loved this to be red, but unfortunately that is not the case. But we have a merge conflict in test.cpp. It cannot handle it automatically. So we have to fix this. So we can see what came from the head, that is our main, is this line, and this came from the remote commit. So in this case there is no telling what actually should happen if these were procedures. So in that case you always need to talk to the other developer. Or when there are 2 separate procedures, you can actually do this. Then we have 2 different procedures, and then we save the file, and then we have to commit it again, like we've did many a times before by now. And let's be a good boy, also add the story number in there. And when we push it, yeah, we have solved all the conflicts manually. Now most organizations don't want you to merge straight on the main, because there is continuous integration and continuous deployment. So they want you to do a pull request so that somebody else can verify that your changes don't break anything. You can configure this on your repository by going to Settings, Branches, and then add a branch protection rule. I set that rule here on main, and I require a pull request before merging. And this should also go for the administrators, because I'm currently an administrator. And then I create this rule. Now obviously I need to invite somebody else, because I need 1 reviewer. So I go to Manage Access, and then I click Add People, and I will invite my clone to be the reviewer. And an invite is sent via email to this person, who can then accept that. My clone receives the email and accepts this invitation. And as soon as you click on it, you are also part of this project. So what we will do now is create a little feature. So we do a git pull. Okay, we're up to date. Am I actually on the main? I think I am. Yes, I'm on the main, so we're up to date. And let's check if we have old branches. Yes, we still have that old 125 branch, so git branch -d for delete. And now be a good boy and create a new feature branch. 126. There we go. It's always important to verify that you're on the right branch. Yes, we are. So let's create a test2 file. Whatever. Created a test2 for new class. Unit test 1. Perfect. This will compile definitely. Now we will need to add that file because this is not under control. Actually, let me show you that status. There you go. So we do a git add all CPP files and we commit it. Even for a little demo, I write a whole story. Okay, it's now committed and now we will push it upstream. Now Git will notice that there is no branch called 126 on the upstream, so it will suggest a command line that will actually create it for you. So you will create on the origin a branch called 126. And this is exactly the reason why I use story numbers. They are unique, so you always have a unique branch on the upstream on the centralized repository. So we pushed it there, so now we can do a pull request for that branch. So I logged into GitHub and I see a different branch, 126, and I can click on it to create a pull request. GitHub is so convenient. Now add a little description for the reviewer. And click create pull request. And that's it. And I cannot commit this myself. Somebody else needs to do that. I logged in as a reviewer and I click on pull requests. And there is the pull request. I click on it. You click on the add review and you review the changes. Yeah, this looks like very solid C++ code that will definitely compile. So I will approve this. You write a friendly confirmation message, you click on approve and submit the review. And then you can actually merge the request into the main branch. So we click on merge pull request, confirm merge, and we don't need this remote branch anymore, so we can delete it. Of course, it's still locally available. So now you can actually check out this whole new main revision. So we move to our main branch, we do a git pull. If you type git write, that will actually help. Git pull. And there it is. We have now actually merged via a pull request, the way it's supposed to be. There is one more very cool and important feature that I want to demonstrate to you, and that is git rebase. Imagine this situation. You are working on a feature and another developer has finished their feature, and that code is now in the main repository. You want to rebase that into your repository because it could affect your work. So let's simulate this by creating our feature branch 666. And we're working on this unit test again. So we're going to add a new unit test in here. This is nice, man. That's a good unit test, yeah. And the other developer in the meantime has changed that same file. And Git cannot merge this because it's code aware. And this is not proper C code. And let's also create a new test file, test3. Because often that happens as well, the new files are introduced that you need to use. Yeah, that's perfectly fine. It's demonstration time, so. And now we go back to our repository and we get the status. Yes, we know that this is changed, so we commit this. We don't want to push right now because we're still working on our feature and it's not working. So what happens if we do a git pull? Well, it will try to pull from the 666 branch on the centralized repository. And that doesn't exist and we don't want to create it. We need to actually check out main and pull the changes from main in. It already says there are 2 changes. So when we do a git pull, there they are. We see that new file test3. Now let's check test2. Whether our unit test is in there. Yes, unit test 2 is in there as well. So we can now actually rebase it. So we're going to check out our feature branch 666 again and do a git rebase and then the name of the branch that we want to rebase from. In this case, main. And you will see we have a merge conflict as expected because that is the test 2. So we need to fix this. So let's solve these issues in the test.cpp. Okay, let's decide to keep everything. That is good stuff. Yeah, save it. And now we need to commit our changes, these merges that we did manually, in order for git rebase to be able to continue. So we commit them. And now we can do a git rebase continue, and there we go. We have all the changes now that were in main, in our feature branch, properly merged. And I do this a couple of times a day depending on the frequency that the main changes. That way you don't lag behind too far. The last thing I want to talk about are tags. Tags are points in your repository history that are significant to you. These are usually used to identify release candidates and releases. There are 2 types of tags. There's the lightweight tag, which basically is a branch that doesn't change anymore. And there is an annotated tag, which basically is a copy of all the objects, including the checksums, the email address, the tagger name, the date, which allows the code to actually be signed with GNU Privacy Guard. And that is something very important when you create a release. So when you use a release, you generally use an annotated tag. Let's create a couple. So first we're going to create a lightweight tag, that is git tag without any -a, and you give that a name. In this case, release candidate 1.0, and we do a -m for a remark again, and we give it a nice remark, release candidate 1.0. Now if you want to push it, this won't push. You actually have to use a push origin and then add the tag name. So we now have created a lightweight tag and pushed it to the centralized repository. Now let's create an annotated tag. Creating an annotated tag is pretty much the same as creating a lightweight tag, except we use the -a. We give it a tag name, version 1.0, and a nice little remark. And now we have created an annotated tag and we push it in the same way. Git push origin and then the tag name. Not tag, but the tag name. That's right. And we push that also to the centralized repository. Now we can see the tags. If you click on the branches, there is a tag tab and there they are. That's our version 1.0 annotated tag. You can see, whoa. Which means it's independent of the other code base. Basically, it stands on its own now. So there you have it, all the basics and some advanced stuff that we use in an enterprise setting pretty much daily. I also advise you to actually use Git on the command line and avoid using the IDE. Sure, you can do a little commit in the IDE, but branching, rebasing, etc. is something that you want to do on the command line and not be obfuscated by the IDE. So I hope you learned something, and I hope to see you in the next one.